My topic is all about the limits theorems. The first theorem is called the limit of a constant. This states that the limit of a constant is itself. If a is a constant, then the limit of a as x approaches c is equal to a. So say for example, we have the limit, or we are asked to solve for the limit of 3 as x approaches 2, the answer is 3. Another example, the limit of 1000 is x approaches 0 is equal to 1000. Okay, let's move on to another theorem, and it's called the limit of an identity function. This theorem states that the limit of a function of f of x is equal x as x approaches c is equal to c. That is, in symbols, we have the limit of f x as x approaches c equals c. Say for example, we have the limit of x as x approaches 0, the answer is 0. Another example is the limit of x as x approaches 3 is equal to 3. So if you are given an identity function, f of x equals x or y equals x, the limit of x as x approaches c is just equivalent to the value of c. Okay, another theorem is called the limit of the sum and difference of two functions. This states that the limit of the sum or difference of two functions is simply the sum or difference of the limits of the individual functions. For example, we are given the limit of f of x approaches c equals L, and the limit of g of x as x approaches c equals m. Then, the limit of the sum or difference of these two functions is denoted and as the limit of f of x plus minus g of x as x approaches c equals L plus minus m. To illustrate this, let's have an example. If the limit of f of x as x approaches c equals 5 and the limit of g of x as x approaches c equals 3, then we are asked to solve for the limit of f of x plus g of x as x approaches c. We just need to add the limit of the individual functions. So the limit of f of x is equal to 5. The limit of g of x is equal to 3. Since we already have the values of the individual limits, if we are asked to solve for the sum of their limits, we just need to add them. So we have 5 plus 3 equals 8. Therefore, the limit of quantity f of x plus g of x as x approaches c is equal to 8. So let's move on to another limit theorem, and it is called the limit of a linear function. This states that the linear function f of x equals m of x plus b, where m and b are any constant. We say that the limit of m of x plus b as m approaches c is equal to mc plus b. What happens here is that m and b retain since they are constant value, and the value of x in your function becomes c in your answer. Since, as what we had discussed in limit theorem number 2, or the limit of an identity function, the limit of x as x approaches c is equal to c. Therefore, the limit of m x plus b as x approaches c is equal to m c plus b. To understand this theorem, let's have an example. If we are asked to solve for the limit of 2x plus 3 as x approaches 3, then What we need to do is to substitute 3 to the value of x, since the limit of x as x approaches c is equal to c. So we have here the constant 2 times the value of x, or the value of c, which is the limit of x as x approaches c. So 2 times 3 plus the limit of the constant is itself. So we have plus 3. 2 times 3 equals 6 plus 3 equals 9. Therefore, the limit of 2x plus 3 as x approaches 3 is equal to 9. This is simple substitution. So, this is our theorem number 4. So, let's move on to another theorem, and that is called the limit of the product and quotient of two functions. This states that the limit of the product or quotient of two functions is simply the product or quotient of the limits of the individual functions. In symbols, if the limit of f of x as x approaches c is equal to L, and the limit of g of x as x approaches c is equal to m, then the limit of f of x times g of x as x approaches c is equal to L times m, and the limit of f of x over g of x as x approaches c is equal to L over m, such that the limit of the denominator should not be equal to 0. In cases where the denominator is 0, the limit does not exist. So, to understand this theorem, let us have a simple example. The limit of f of x as x approaches c is equal to 6, and the limit of g of x as x approaches c is equal to 1/3. So, if you are asked to solve for the limit of the product of f of x times g of x as x approaches c, we just have to multiply their individual limits, 6 and 1/3. So we have 6 times 1/3. 6 times 1 is 6. 1 times 3 is 3. 6 divided by 3 is 2. Therefore, the limit of the quantity f of x times g of x as x approaches c is equal to 2. How about the quotient of the two functions? We have the limit of f of x over g of x as x approaches c equals the quotient of the limit of the individual function. So we have 6 over 1/3. Now, since our denominator is a fraction, we multiply our numerator to the reciprocal of the denominator. So we have 6 times the reciprocal of 1/3, which is 3 over 1. 6 times 3 is 18, divided by 1 is 18. Therefore, the limit of f of x over g of x as x approaches c is equal to 18. So, now let's move on to another limit, and that is the limit of the n power of a functions. This states that the limit of function with power n, where n is any integer, is simply the limit of the function raised to the power n. To understand this one, let's have a simple example. What if we have the limit of 3x minus 3 squared as x approaches -2? What we need to do is to solve first the limit of f of x before we raise that 1 to the power n or the power 2. So far the function inside, we have 3 times -2 minus 3 raised to the power of 2 equals 3 times -2 is -6 minus 3 raised to the power of 2 equals, simplify what's inside your parentheses. We have negative 6 minus 3 equals negative 9. Negative 9 squared is equal to 81. Therefore, the limit of quantity 3x minus 3 squared as x approaches negative 2 is equal to 81. So let's now move on to the last theorem, and that is called the limit of the nth root of a function. This states that the limit of nth root of function is simply the nth root of limit of the function, provided that if n is even, the value inside the radical sign should be greater than 0. For example, the limit of the fourth root of 3x plus 7, as x approaches 3, we can simply substitute 3 to the function inside our radical sign. So we have the fourth root of 3 times 3 plus 7. 3 times 3 is 9, so we have 9 plus 7, so we have fourth root of 16, and the fourth root of 16 is equal to 2. Notice that the value of our index is 4, which is even, and the value inside the radicand is greater than 0. Therefore, the limit exists, and that is equal to 2.